And a special thank you to our sponsor partners. Sorry.
Sir,
Okay, so thank you to our sponsor partners, Toyota Kentucky, and Mark, without which we could not offer these. All right, sorry, a little technical issue there. It kind of threw me off. So you got to love live TV, right? This is fun. So anyway, let me go back and say thank you again to our corporate partners, our sponsors, Toyota Kentucky, Kentucky Upscore, and Lexmark. Again, without them, we wouldn't be able to offer these amazing summits. And if you know anybody that works at one of these amazing organizations, please say thank you to them for us and for yourself. You know, at Kentucky Science Center, our mission is to promote science literacy, nurture lifelong learning, and prime that STEAM workforce pipeline. And what that last part means is really what we're here to talk about today. What we want is for you to take away from this is to be aware of all the amazing STEAM careers and the possibilities that are out there. It doesn't matter if where you want to do it, you don't need to leave your hometown to have an amazing STEAM career. That's what I want you to take away from this. The possibilities are really endless here, and you can have a great career wherever you are. So my challenge for you today is this: while you listen to these speakers, dream about what lies ahead for you. You know, the possibilities really are endless. The STEAM careers of tomorrow, probably not even invented yet today. So think about it, dream about what you want to be, what you want the future to be. It really is up to you. I know you can make it whatever you want it to be. So again, thank you for being here. I'm going to turn it back over to Veronica and let her kick off the morning, and have a great day. Thank you.
all right, thank you so much, Mike. Okay, so I get the pleasure of introducing all of our amazing speakers. So give me one moment while I put up our bio. So the first speakers we have today are going to be from U of L. They are Dr. Stephen Koenig and Dr. Gretel Monreal. Am I saying that name correctly?
Yes.
Yeah, excellent. So they are faculty members in the Advanced Heart Failure Research Program at the University of Louisville. Their laboratory studies, they use circulatory support devices used to treat heart failure. Dr. Monreal and Koenig perform experiments in their labs, publish manuscripts on their experimental findings, write grants and contracts to fund new projects, partner with companies to develop new technologies that may one day help patients with heart disease. They teach and mentor engineering, medical, and science students, and physician trainees, and engage young people like you all in STEM fields by promoting cardiovascular sciences and heart healthy living through their Heart Wheels STEM mobile outreach program. Did I miss anything?
I think you captured it quite well. Thanks, Veronica.
All right, well, without further ado, I will pass it over to you. And again, I will be monitoring the questions for you all, okay?
So good morning, everybody. Thank you for joining us this morning. We're very, very excited to share with you the things that we get to do on a daily basis that when we're your age, we're only dreaming about being able to do. And our love and our discipline in working in STEM-related fields have given us the opportunity to do what we think we have some of the best jobs in the world, and that we get to work with medical devices. So let me introduce myself first. Again, I'm Dr. Stephen Koenig. I'm a biomedical engineer. I actually have joint appointment both in cardiothoracic surgery, where I get to work with clinicians and medical students, and then also on the engineering campus, where I get to work with engineering students. And I've been in this field for now 25 years, doing research, mentoring students, and then also serving nationally and within the community. And my colleague, Dr. Monreal.
Yep, I'm Dr. Gretel Monreal. I have a PhD and then a master's degree, and before that, a bachelor's of science degree. When I was a little girl, I always wanted to do something with science. So now I get to do that. I'm a professor at U of L, and I study heart disease. And we're trying to find ways to use mechanical devices to help patients that have heart disease and try and help fix their heart and their circulatory problems. And so my colleague, Dr. Stephen Koenig, and I, we've worked together for more than 20 years trying to solve these problems. So today in this time, we're going to tell you a little bit about the heart and then show you some of the devices that we study to try and help sick patients.
And so if you look at our advanced heart failure program, as Veronica had introduced to us, if you look at the issues with heart failure, it's one of the prevalent problems in the US and worldwide. And one of the issues that occurs with heart failure is over periods of time as people progress with the heart disease, there really is no known cure for heart failure. It's really learning how to manage the systems, have the best, healthiest lifestyle you can. But there comes a point that in patients who suffer from heart disease, that there are no more cures to do it other than potentially doing a heart transplant.
Yeah, and so Dr. Stephen Koenig and I have a model of a heart right here. And you can imagine, you know, if a heart is sort of ball-shaped, this is a plastic heart that's been cut so you can see the inside chambers. This chamber here is the left ventricle, and it's very thick and strong, and this pumps blood to all the rest of your body. But in heart failure, it's this chamber that gets sick and doesn't work very well. And so eventually over time, you can manage patients that have a problem with this chamber using medicines like drugs, but that only works for a little while. The only cure ultimately for someone with heart failure is getting a heart transplant. And you hear about heart transplants in the news and you know, maybe from your family members, but even though about 4 million people in the United States have heart failure, do you know how many heart transplants are done in the US a year?
Surprisingly, it's very, very small number of patients that get that life-saving treatment.
2,000, about 2,000 heart transplants a year. So if 4 million people ultimately need a heart transplant to fix this sick pumping chamber, but we're only doing about 2,200 a year, we need to come up with alternative ways to help these patients.
And so be surprising to hear, but since the 1960s, as early as the 1960s, clinicians, scientists, and engineers who've studied how heart disease forms have looked at trying to come up with alternative therapies. And one of those are using mechanical circulatory support devices, specifically what they call an artificial heart or ventricular assist device, which is basically an electromechanical device that helps assist the failing heart by restoring blood flow to the rest of the body and maintaining good pressures.
That's right. And the devices that we're going to show you to start with, the patient's sick heart, the doctor wouldn't go in and remove it. The patient had their sick heart still in there, but they also got alongside it a mechanical pump to help that sick heart do its job of pumping blood. The first device we're going to show you is actually quite large and quite terrifying, and it weighs about 5 to 6 pounds. This device
is the HeartMate XVE. It's an electromechanical device that operates with a pusher plate that pumps back and forth, that takes blood from the sick, diseased heart, and it's what's called its ventricle, and then pumps it through the aorta to go to the rest of the body.
That's right. So the way this worked, Dr. Stephen, if you can hold that in the view. So this part of the device would go down here into the ventricle. Blood from that failing heart would be in this chamber here. This chamber has a pneumatic drive that would pump blood. It's a pusher plate mechanism, and then shoot the blood, if it's on camera, up this graft where the surgeon would sew it to the aorta. So this device would have to fit somewhere inside the patient. Now, sometimes it wouldn't fit in the patient and you'd have to put it in the abdomen, but unbelievably, 5 to 6 pounds, this is sort of what we started with a pumping device.
And in addition to that, you know, there are a number when they're developing these devices, and it's what's called preclinical work. Before ever it gets put into a patient, they do a lot of engineering design, and they go through multiple iterations to make sure that the device provides the blood flow at the pressures that's needed. They need to make sure it's safe and reliable, and it's going to be effective. And so that first XVE device that Dr. Monreal just showed you had a lifespan typically of up to 1 year in a patient before there could be potential issues with the device or in the patient itself. And so it was used, it was called a bridge to transplant, meaning people who were waiting for a heart transplant but were very, very sick, they used to help that patient until they could find a donor heart available. And sometimes that could take up to a year to get a donor heart. And so these devices then started to become smaller and smaller in size. And so if you look at what's currently available today, what's called the HeartMate 3 device, as you can see, it's become much smaller. And so here's the inflow going into the blood pump that goes into the apex of the ventricle. So it goes from the sick heart into.
So blood would be pulled into this pump. This pump, instead of pumping, has an impeller in there, like a little propeller, like on the back of a boat, that would spin the blood around, shoot it up this graft, and the surgeon would sew this graft to the aorta. So it would help this failing pumping chamber by sending blood to the rest of the body. Now, this device is currently being implanted in people, and you can see the size difference compared to this device, the XVE, to this, which is the HeartMate 3. This is smaller than a hockey puck. Now, it's electric, so the surgeon has a power line that he has to tunnel out the patient's skin, and the patient could plug the power line into AC power or a battery pack that they could wear like a little fanny pack. But the beautiful thing of these small pumps now is you have no idea that a patient has one implanted in their chest. And the battery packs are so small that you can't even detect that they have a fanny pack powering a device like this. These devices, we've learned a lot since these days. So the patients recover faster. These devices last longer. They're smaller, so you don't need a big traumatic incision. And so all in all, patients do very, very well on these devices.
And from a STEM career potential, it's a very multidisciplinary team of scientists, clinicians, and engineers that are involved. You know, one aspect of it is just designing the pump. You know, what should be the best pump? How much power does it require? At what pump speeds, in terms of how fast you want the impeller to spin, do you want it to do? What are some issues in terms of pressures and stresses, and how does that affect the blood? And so there's a lot of engineering that goes into the pump design itself, but there's also a lot of science in terms of proposing scientific questions and hypotheses of how is this going to affect the blood? How is it going to change the myocardial tissue that the heart has? You know, over time, is there going to be a change in the structure or the function of the heart muscle? And then clinically, there are a lot of questions in terms of how do you maintain patients? Because when a patient receives one of these pumps, they want to go home right away and they want to return to their normal daily activities and they want to enjoy a really good, high quality of life. But sometimes there's some clinical issues that arise in terms of how you manage the patient. But as students and in future careers, you have the opportunity to design pumps as an engineer, ask scientific questions and do research, or even become clinicians one day, and how do you best treat patients?
And like Dr. Stephen Koenig and I, we're involved in testing these devices for companies. We have a laboratory at the University of Louisville, so we don't have a factory. We can't manufacture these, but the company can call us up and say, hey, we've made a bunch of these, but we need your help making sure they're safe for patients. So some of the devices that are still in the works that haven't been tested in human beings yet are getting smaller and smaller. So this is a pump that's not available that doctors can put in yet, but you see already, this is the one currently used. This does the same function, but we're getting smaller, which is really, really neat. And then we actually have tiny, tiny pumps that can even be placed by a catheter that Dr. Stephen Koenig is going to show you next.
So one of the blood pumps that we were fortunate to work with a company called Abiomed, which is up in Danvers, Massachusetts, developed a catheter-based pump, which instead of going through an open chest procedure, you can actually go through a peripheral procedure. The way this pump works is it sits in the apex of the heart, down in the bottom, and then it comes up like it's going through a straw and goes across the valve and then comes through to the aorta.
So there's a tiny pump right here that does the same work as this big pump here and as this pump that's currently being used, amazingly. But now, instead of having to open the chest for a big surgery, a cardiologist who's a heart doctor that doesn't do surgery, but he does more peripheral procedures, he can make a little hole in an artery in your leg, pass this pump, snake it up into your aorta, and put it in the heart, and it will do the same function as these big metal pumps.
And as Dr. Monreal had shared with you, again, going to some of the STEM fields that are involved in the development of that device, as you can imagine, as these pumps become smaller and smaller, in order to have the same amount of blood flow to go through a smaller opening, they have to operate at higher pump speeds. So the impeller that basically spins inside that catheter, instead of spinning at, say, 4 to 10,000 revolutions per minute, now you're upwards of 35 to 40,000 RPM per minute. So there's a lot of engineering that goes into computationally modeling, using computer models to predict what are those flows going to look like. Are they going to cause destruction to the red blood cells?
Well, you can imagine something spinning so quickly is winging those red blood cells around. So sometimes those red blood cells just get shredded. And so we're trying to find ways to minimize that so that doesn't cause more problems in patients. You want to do that?
And so,
Oh, okay. So all of these devices that we showed you are really, really big. So you can imagine this doesn't fit in a child very well. So the last device we're going to show you is the one that Dr. Stephen and I are working on right now. And it's a tiny little pump that does the same thing, but we're going to do it for newborn babies because newborn babies sometimes have heart disease. So we are in the process of helping a company make a pump like this, but for newborns. Oh, unless there's questions.
We do have a question I can ask you, or would you like me to go ahead and ask the question before you get started?
We're happy to field questions.
yeah,
right.
any time if people have questions. Yep.
All right, so this question is from Lucas. How did you end up in your job or field? Did anything specifically inspire you? Great question.
It's an outstanding question. So it's the same type of question that I asked medical device design students in our bioengineering class here at the University of Louisville. First day of class, I asked the same one, you know, what do you do? And I think you'd sort of be surprised, at least not so much for me anymore, is a lot of it is something personal. You know, we mentioned earlier, Dr. Monreal mentioned earlier, heart disease is very prevalent in the US and worldwide. So it's not surprising that we have family members or relatives who suffer from heart disease. I'm no different. You know, my family has genetic issues in terms of heart disease. So I was very, very curious about it. And that's how I kind of got involved. And then through my service in the military for 5 years, I did cardiovascular research for astronauts and pilots. And so the transition into studying heart disease between that experience in the military and then a family history was really kind of what got me motivated. Plus, I just loved math and science.
Same with me. I knew I wanted to do something with science and biology, and here I am.
That's awesome. So we do have another question. So did you have any hard times when you were in school? For instance, did you deal with any bullies or any hard times in classes?
Fantastic question. Oh yeah, I was a nerd. I was bullied, marginalized. You know, I did well in school, but I also have my share of C's and D grades all the way through college. I was your typical B student. I went to a state school for my degrees. I had loans like everyone else. I only finished paying them off 9 years ago. And so, yeah, the trials and tribulations of being a student, I think everyone has encountered those sorts of things. But for me, if I could time travel back and tell my younger self at 12 or 13 years old, you know, when puberty's the worst and school's tough and you're learning, getting a taste of what adulthood's going to be like, I would tell myself, just keep plugging away and you'll be fine. You know, you can't control other people, how they think or feel or act, but if you work hard, you'll do fine.
I would add very similar. I had very similar experience as Dr. Monreal did growing up. I would just add, when we look at taking on students or inviting new staff or collaborating with other faculty members, mentioned multidisciplinary clinicians, scientists, and engineers, the common thread when we look at everybody, it's not what grades you had or what school you went to or how smart you are. It's number one, you love what you're doing. And if you love what you're doing, you're never going to give up doing it. Two is, Dr. Monreal mentioned hard work. It's having that grit. It's that we fail all the time. Unfortunately, in school, so many times, if you fail a test or you work on a project and it just doesn't work right, you think you're a failure or you'll never succeed or things won't work. And then the reality is we fail all the time. The number of times these devices have gone through different design iterations and testing, and even when we do the testing, a test doesn't go right. What separates us from everybody else is we don't give up. We have that can-do attitude. We work as hard as we can. We try to find solutions. We accept and embrace failure, and we try to learn from our mistakes. And we're supportive of each other. We help each other, and we do whatever we can to do it. And the eye has always been on, especially in our field, of how do we help patients? That the hard work we do and the people we love to work with, at the end of the day, we hope that all that hard work and time and effort is eventually going to help patients. And that's really kind of in the end what motivates us.
Absolutely. I always learn way more from my failures than I do sometimes when things go perfectly right. So thank you for those questions. Please keep them coming. Go ahead, continue with your presentation, and I'll pop back in with more questions, okay?
Sure. So a couple more things that we could share with you.
Well, we can go back to, there's that discrepancy. There's so many people with heart failure, and heart failure is a fatal disease unless you can get that patient a heart transplant. But another device that we haven't shown you yet that we're going to show you right now is the most extreme solution. Sometimes a heart transplant isn't available, but that patient's going to die of heart failure when this pumping chamber fails. And sometimes the entire heart will fail. In that case, in extreme situations, the surgeon can remove the entire native heart and replace it with a device that's called a total artificial heart. I'm going to let my colleague, Dr. Stephen Koenig, tell you about this device because incredibly, back in the 1990s, Dr. Stephen was a part of the team that tested this device preclinically in our laboratory and then had the privilege of seeing the first sick patients who are going to die in a couple days actually receive this device and benefit from it.
So this is the AbioCor total implantable artificial heart that was developed also by Abiomed, a company we work with up in Danvers, Mass. They came to the University of Louisville to work with the cardiac surgeons here, Dr. Gray, Dr. Dowling, and their team of scientists and engineers and other clinicians and support staff, and did all the preclinical testing along with other key universities.
And so preclinical testing means making sure it doesn't overheat, making sure it pumps the way it's supposed to, making sure that it's not going to hurt the patient. We test all of these things in our laboratory first.
And so in this particular device, they spent close to 5 years making sure that it did the job it needed to do. It provided the blood flow that was needed for the patient at the pressures it needed to maintain, and that it was going to be safe and reliable. Because once you take out the patient's native heart, this device has to do all the heart pumping for the entire body, going to the brain, the lower body, the upper body, the lungs. And so it can't fail. This is a device that if it fails, can end up in a catastrophic result.
And you can imagine this device, since it's replacing the entire heart itself, it has to have all those chambers. So as you can see, there's a left ventricle chamber, the main pumping chamber. There's a right ventricle chamber that pumps to the lungs. There's these things called sewing cups that attach to the left atrium and right atrium on the heart itself. And then in this silvery part here is a pusher plate mechanism that shuttles back and forth. So this heart would go pump, 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 pump. And this entire machine was inside the chest of the patient after the surgeon removed their sick heart.
As Dr. Mario shared, what made this special compared to a lot of the other devices that we've showed you earlier is, again, it replaces the whole heart and it's totally implantable, meaning there's no cables, no lines, no electrical systems that come out. So one thing you could look at and say, okay, well, how did they power and talk to the heart? And they used a wireless system that allowed transcutaneous, which just basically means they could transfer power outside the body to inside the body. And again, that required engineering and science and mathematics to understand how to do that, to be able to power that device continuously, as well as talk to it, so that if it needed to make changes to how that device was operating, they could do that without having to go back into the patient.
And so you can imagine from a STEAM career standpoint, the thousands and thousands of people that were involved in making this device a reality. You had experts in this material and the plastic parts and the metal parts. You had experts in the device testing, like Dr. Stephen Koenig. You had veterinary experts, surgeons, nurses, anesthesiologists, experts in blood technology and fluid dynamics and electronics and all the energy systems. It was a huge team of people all coming together to work together to try and find a way to help really sick patients.
And so if you really like working with patients, similar to Dr. Monreal and I, there are many different ways to do it. Some people want to be engineers. They like to design and build things. Other people are very curious, so they want to ask scientific questions and hypotheses. You know, what happens? How do you balance the left and the right side of this device? You know, how do you maintain the blood pressure for that patient? And so, you know, again, coming back to what Dr. Monreal and I do, along with our other colleagues here, Dr. Slaughter, who's the lead cardiac surgeon, we're known here at the University of Louisville as probably one of the top 5 centers in the world that do preclinical testing and helping companies throughout the world develop these very sophisticated but very important devices to help patients. And so if you look behind us, we won't walk you through it, but you can see this is one of our test setups that we call a plastic patient. That basically it's made up of different types of tubing that simulate a patient's blood vessels. It's filled with different sensors to measure blood pressure or pressures within the loop. And then we also have a flow probe that we can measure the flow going through the loop. And so what these types of setups allow us to do, this plastic patient, allows us at a very early stage in the design and the development of the device, test that device to see what kind of challenges we have, what works well, what doesn't work well. In the next set of design iterations, what do we need to look at and understand?
And that's where you guys in the future, if you pursue STEAM careers, maybe you can help us figure out the problems with sick hearts and help us make devices that are even better than the ones that we're using today.
You know, and some of those challenges that we share, again, with a number of different students is there a way we can develop a battery that lasts longer than 4 hours? Can we come up with batteries that last maybe 10 times longer than that? Just think about a patient, you know, if they have to disconnect from a AC power supply and run off a battery, the longer you can run off a battery, the more better quality of life you have. Are there ways we can come up with where these, like the AbioCor, are totally implantable so that there are no wires or cables coming out? Think about it. If you wanted to take a bath or you wanted to go swim in the ocean, you know, are there ways that you can do that and having a totally implantable system? You know, are there ways that we can make it last longer so that instead of 1, 5, or 10 years, these could last for much longer periods of time?
Do you have a question? If you don't mind. So you mentioned that you work with people all over the world and you have the device behind you. How do you change things for like different altitudes or different areas of the world, or even if you're going to space? I know space is a popular topic for lots of people.
Well, for working with people all over the world, since we're a very well-known center, the nice thing is they send us the devices to test. And so this device here is being, the concept is originating from a team in Florida. So they will ship us via UPS a whole bunch of their pumps, and we come up with a testing plan, an experimental protocol together, where we figure out what needs to be studied, and then we study it here in the laboratory, and we send them the results. The nice thing is that we work well with a lot of different people, so it takes people from all over to come together and come up with, okay, well, maybe we need to make this part out of a different material, or maybe we need to make this part longer or shorter, or the pump spin faster. So we do all those things collaboratively with all our friends in this field.
As Dr. Monreal shared, and especially having now gone through the whole COVID where things were done virtually and remotely, as those remote technologies to connect everybody throughout the world have gotten better and better, we're able to do these. Like today with our Heart Wheels program, we're able to share with you, even though you're not with us in the lab right now, we can share with you some of the things that we get to do. You'd be surprised to know that a number of the issues with that particular device that Dr. Monreal just shared, things like the magnet technology is being developed by a collaborator in California. The design for what the flow characteristics should look like in the pump is designed by a group in Florida. In New Jersey is a group who's developing the controller that does all the computer communication and processing and electronics by a group in New Jersey. And here in Louisville, Kentucky, we get the assembled device, we test, and then we share all that data. And if they want to see real time, we can actually send streaming data, audio, video, where we can do these virtual experiments with them.
That's awesome. That kind of ties into my next question. So how do you stay informed and competitive in your field when science or society and technology seems to move so quickly? So you kind of touched a little bit, but what are strategies you all have to kind of stay up with changing technology?
That's a fantastic question. Science does move very quickly, and sometimes it could be overwhelming. You may be on top of what's new in the pump world, but you sort of lose track of what's new in the blood world. And so it's a lot of reading, it's a lot of thinking, it's a lot of talking with colleagues. Sometimes we're able to go to scientific conferences where a whole bunch of people in the field come together. Some people just talk informally. Maybe we'll go out to lunch and talk about, hey, I'm testing this device. Have you tested it before? Have you had any problems? Or sometimes we can sit in an audience and listen to other people's presentations. Those presentations tend to be the cutting edge things that haven't been published yet, that haven't been in the news, but we can sort of get an inside scoop on, ooh, they have sort of what we're doing over here with our testing setup, but they've scaled it down to a really tiny profile. Maybe we can do that too. Or maybe they've bought a cool piece of software that we don't have yet that we can buy and teach ourselves how to use and then start using that. For us, it's important to stay on top of using the cutting edge resources because, as you can imagine, with software, even something like Windows, Windows 10, Windows 7, Windows XP, it's so old already, even though we were using those just a couple of years ago. So the same thing with our own fields, software and hardware technologies. It's a matter of being informed and also being willing to try them out.
Absolutely. We teach our students all the time. We use the term lifelong learning. We love it. So we want to keep learning and reading about it. We look forward to hearing and being open to new ideas and new suggestions. It's not like when you graduate high school, you graduate college, you're done learning. It basically gives you the building blocks so that you do self-learning. You're motivated to learn on your own. You want to know more. You want to see what other people are doing in their labs and in their programs. And then you just learn from that and you take away and then you apply to what you're doing.
Well, and the other thing that's important for me and Dr. Koenig is to have fun. Always to have fun while we're doing it. We play music. We have disco lights. Sometimes we'll put on if we celebrate an achievement that we're proud of. And so we work very, very hard, but we also try and have a good time while we're doing it.
Absolutely. That's what we like to do at the Science Center. Our motto is have fun, do science, and inspire lifelong learning. So absolutely, you got to be passionate and have fun while doing it. Do you have a personal favorite product that you've helped design, or do you have a particular project that you guys really love to share about?
I wouldn't say it's necessarily, it's for us, it's not like we're doing the same thing every day. We look forward to every day learning something new and having a new experience. It's not like you learn how to build one device and then, the other 50 devices we've been part of developing, it's the exact same thing. It's always something different. So to me, what I really love doing is coming into work and learning something new, meeting somebody new, coming up with a new idea. And sort of that's kind of my goal every single day is, hey, it's a new day, especially mentioned earlier when you fail. When I fail, I just don't give up. I try harder and I keep trying to think of, is there another way to do it? Did we miss something? Is there something in literature that we can turn to? Is there a colleague we can ask? And then when you find that solution, you kind of have that eureka moment. That's what I really enjoy. It's never a particular device or a particular product. It's always the next new relationship, the next new project, the next new experience, or the next new piece of information, because we never stop learning. Just because you have a degree doesn't mean that you stop learning and you stop, experiencing new things. That's what's really the most fun for me.
Agreed, same thing.
All right, so I would like to open this up for some more questions. Do you have anything else you'd like to show us? So we have final questions for you all.
Those are the goodies that we brought along, but we thank everyone in the audience out there. I wish I could see all of your faces. I hear there's people from Rhode Island even, and so it's a huge privilege for us to be able to show you guys what we do here. We love it, and if I could fly all of you in to come spend a day or a week with us in our laboratory, that would make me so happy.
All right, one last time for questions here, looks like. Do you have any advice? Actually, one last piece of advice for all of the people watching today.
Oh, for everyone out there, just keep working hard, be confident in yourself, have grit and determination, and love what you do, whatever it is. If you become an artist or a bus driver or a heart surgeon or a chemist or whatever, as long as you love it and it brings you great joy and fulfillment, and you just keep plugging away, don't let the bullies turn you down, don't let getting rejected by colleges turn you down, or bad grades or any of those things that are scary. You just have to believe in yourself and love what you do, and at the end of the day, and that's all that matters.
I agree 100% and share the same sentiment as Dr. Monreal. Don't let anybody tell you you can't do something and believe it. Just believe in yourself and you'll be amazed at what you're able to accomplish and achieve, and just really love what it is you're doing. You'll notice it comes across, we come into work every day and we don't look at it as work. It's just on to something new. We don't let failures, we don't let other things take us down. Goal is try to learn something new and have fun doing it. And just believe in yourself, like Dr. Monreal said, and great things lie ahead. There are much better days that are ahead. You'll have your good days and your bad days, but you'll have way more good days than bad days.
Awesome. Well, thank you so much again for your time. Again, if anyone has questions they come up with later, feel free. We are going to send contact information out to just after the program, or you can reach back out to us and we can relay those questions as well. But thank you so much for your time.
Thank you, everyone.
Bye.
Well, that was awesome. Again, this was U of L, Dr. Monreal and Dr. Koenig. So I also get to, hi. I also get, hi, Dr. Tom. I'm going to introduce you in just a moment, okay? You pull up your bio. All right. So here we have Dr. Tom Lucas, Dr. Tom Lucas. So you grew up in Eastern Kentucky before moving to Louisville, where you got a PhD in electrical engineering from the University of Louisville. So before you started teaching, you did some research in 3D micro electromechanical systems. You might have to talk a little bit more about that. Also doing sensor and actuator design. And now you are the assistant professor of practice at Purdue University, where you teach courses about embedded digital systems for advanced manufacturing. So did I cover it pretty well?
Yes, that was great. I'll add a little more to it. Thank you so much for the introduction, and thank you to our previous speakers. I'm going to hit many of the same notes about the amazing opportunities in science and engineering for everyone, regardless of your background. Just to expand a bit on the introduction, I was very fortunate in my high school system that right across our parking lot was a vocational and technical school where I spent most of my time in the computer repair classes, sharing spaces with the auto body and woodworking type classes. I did not envision being a college professor at a school of engineering technology when I was in my teen years. I just like taking things apart, putting things together, seeing how they worked, and really interacting in a hands-on way with the world around me. I transitioned into engineering at the University of Louisville from there, and really built out the foundations of my view of engineering as I went through a bachelor's, master's, and finally a PhD in engineering, electrical and computer engineering, specifically in micro electromechanical systems and microfluidics. So we heard in our previous speaker, they were developing implantable devices at the scale that they could hold in their hand, but that the advances in technology were pushing that smaller and smaller and smaller. And so the type of research work that I was involved with was making pumps and moving parts that could squeeze things at the size of a cell. So if you grabbed a small bundle of cells out of a heart, could you squeeze it like poking the top of a cake to see if you baked it long enough to determine the health of that cake, if it came out right or not? Could you squeeze a bundle of cells and capture information, determine the health about those cells? And I worked purely from the technological and engineering side of implantable medical devices and interacted at U of L in many of the same bioengineering circles that we just heard about. From there, I went on to do research and design in a number of medically related device situations. And then I started to turn my focus on reflecting on where I came from and how to expand that pipeline for others. And so I ended up transitioning into teaching at a community college, Ivy Tech Community College in Indiana. And then a few years after of teaching there, I moved to Purdue University at a satellite campus, not the far north Purdue University main campus in Indiana, but in a satellite campus right across the river from Louisville in New Albany. And so now I'm, able to have the opportunity to interact with people all around the region, both sides of the river, sharing where I came from, helping build the pipeline to bring people into the careers like we heard about in the previous talk, and many, many others. The focus of what I really am going to zoom in on today is related to manufacturing. And so I'm going to go ahead and share what I've got. And Veronica, can you verify I am sharing my screen there?
It looks like it's starting to pop up. Yep, it just popped up.
Wonderful, thank you. So today I'm going to be talking about trends in manufacturing, how ingrained manufacturing is in the Midwest in particular, and also pathways into a career in engineering and technology that are available to you wherever you are in the state of Kentucky or in southern Indiana, or even further out. I know we have folks from all over, which is amazing. I'm hoping you'll find something useful in this presentation, no matter where you're at. But just to warm us up to diving in, I'd like you to look around you right now, wherever you may be, and just think about what around you is man-made in some way. Even if it's made of natural materials, has been crafted in some sort of man-made way. If you even look at this picture that I'm providing for you now, you can see many examples of just that. In fact, it's more difficult to think what is not man-made that you see around you. Maybe you have an apple or a banana sitting on your desk and then you can see something. But even looking at this picture, the desks, the chairs, the blackboard, the TV, the panels in the floor were all man-made in some way. And all of the infrastructure around us had to be created in some fashion. And so the two questions I really want to highlight are, how did those things get there? They weren't picked from the ground or grown from a tree. And so how did they come to exist? Where did those desks and chairs and floor panels, ceiling panels, the door, where did all that come from? the tablet that you may be watching this on. It all came from manufacturing. Natural goods and materials have to be formed by people and transformed into what we need all around us, into the shapes, into the structures, into new materials, and manufacturing is the process to do this. So that's the how, but the why though, why did it get there? And what I mean by that is, what brought about the creation process of that particular shape? What were the tools used? What were the techniques to make those items? And the why of how it got there is engineering. And so what I want to discuss today are the two facets of how did things come to be, what the future of manufacturing looks like, and then also pathways for you to get into engineering from wherever you are, because we have many, many, many channels distributed all around our country that brings you into a career related to manufacturing, engineering, and technology. So again, manufacturing is the process of taking raw materials and turning them into finished goods using tools, human labor, machinery, chemical processing, and so forth. While engineering is the design and finding out how to use what we have available to do the manufacturing. So frequently while balancing social factors and cost, economic factors, environmental impact. So engineering ties in a lot of the science of can something actually work, along with a lot of our social and economic factors that we rely on as people. And so while engineering is a scientific field, it has a ton to do with creativity, empathy with your customers and users of things that you're designing for, suited to people who want to be creative, inventive, curious, hands-on. A lot of the notes we saw from our previous speaker and from the CEO of the Science Center as well, all reiterating this point. We need curious, creative, inventive individuals in STEM fields. I view engineering personally a lot like, has a lot of analogy. And for example, an artist may study artists in the past to learn their techniques and how they did things, and then can rearrange those and make something new. Or someone who's cooking can learn from traditional cooking techniques and then put their own spin on things. Engineers learn the tools and the techniques and the math and science that we've come up with over the past hundreds or more years, and find out how to fit that to address our modern problems, advance the state of what we can do, and try to add benefits to ourselves and to everyone around us. So just, we already talked a bit about my background, but I did move into teaching in Bloomington, Indiana, but I started out in Eastern Kentucky before coming to Louisville. You have access to education pipelines no matter where you're at. This was my particular path. And why I highlight this is I worked at many different levels in manufacturing related areas as a student, and after school, I worked side by side with folks at the entry level and technician level, technology, manufacturing space. I then moved into teaching at Ivy Tech, where we, particularly in electrical engineering technology, offering 2-year degrees. So folks going in at the technician level, but on a pathway through a company that would lead through engineering and possibly to other places. Since transitioning to Purdue University, right across the river from Louisville, I am now part of a 4-year degree program. So folks that are entering engineering level positions and then moving on from there. So it's given me a really interesting, in my view, just total picture of the manufacturing space from a lot of different angles. And so in my teaching career, I'm helping to support the pipeline of getting anyone from anywhere into STEM careers that are going to set you up to have a good, productive, and positive, happy life post your middle school and high school experience. So we're going to go into the first parts a bit about manufacturing, and our last we'll wrap up with options of engineering after high school. But I want to start with a little history before we go too deep. You may be familiar broadly with the term an industrial revolution if you had a history course that touched on that. But historical scholars divide industrial revolutions into a few phases. For as long as humans have been around, we've been making things, whether it's just shaving a stick to a sharp point, or using tools to help us capture food or create structures to live in. But in the late 1700s, really rapidly advanced due to mechanical production, having railways and steam engines for the mass transport of goods. So suddenly, you can't just manufacture with the raw materials around you, but you can get things from the other side of the country. And so that opened up a lot of new opportunities for making new things. In the late 1800s, you had mass production and the assembly line became far more popular. The electric grid was rolling out in mass, and you now had factory production lines that were producing products faster than ever before and at a more customizable level than ever before. So the amount of production and the way things were produced radically shifted. In phase 3, we had prevalence of computers and computing devices. So now we could have calculated movements on those factory lines. It's not just a human person doing a repetitive task, but we can start to integrate aspects of computers and robotics. And in fact, we're on the tail end of that phase 3. But robotics are pretty synonymous with most manufacturing processes. They do a lot of tasks as they're currently fitted that humans are not totally thrilled to do always, such as carry very heavy loads, do repetitive, extremely repetitive tasks, or work at high speeds beyond how a human may want to work. And so it's frequently framed as robots or maybe replacing some human operations, but it's more of a case of robots are taking over activities that humans are less suited for, and humans are moving more towards the more creative aspects in the design of systems that keeps our brains and our physical hands and everything more engaged. And so a lot of the dangerous type activities are being offloaded to robotics. And you can see on this chart, this is in millions. So about a tripling of robots in industrial settings. But robots are where we're at, but we're in the middle of a next giant leap. And for those of you watching, 2006 may seem like a really long time ago, but in the scale of industry, that's not long at all. But these items did not exist in 2006. Things that are everywhere today. The first iPhone, Kindles, 4G communication, Airbnb, Android, Oculus, Instagram, those things did not exist in 2006, which was not that long ago. And in the advances since then, we've had a huge booming of data infrastructure brought on by the internet in the ways that we can connect. If you look historically at manufactured products such as airlines and automobiles, to have 50 million users interact with that particular piece of technology, it took decades. It took almost 70 years for 50 million people to use airlines. Still 18 years for 50 million people to interact with an ATM. Zoom forward a little bit, YouTube reached 50 million people in about 4 years. And even our most recent, on this plot example of Pokemon Go, reached 50 million people in 19 days, which is an amount of distribution that is completely unheard of in all human history. And that's facilitated by the access to data and data infrastructure, which is moving data around on the internet that we have now. And so the possibilities because of that data communication are what launch what we're in now, or starting now, which is the 4th industrial revolution. Or referred to as Industry 4.0. And there are a number of aspects that are highlighted here, but the ability to do things mobily and wirelessly, having computing done in cloud situations at off-site locations, having smart connected devices that can operate in different ways based on sensed parameters in front of them. You have ability for mass customization, choosing as the customer through an internet website what type of product you would like, what color do you want, what size do you want, and having the ability to have those manufactured to what you specified is something that did not exist in prior iterations of assembly lines, not at the direct customer scale that it is becoming possible now. And so as a concept, the idea of data running a lot of the operations in a factory can broadly be categorized as a cyber physical system. And it's a system of collaborating computational elements. So interaction, the website that the user may order something through, interacting with the computer systems at a manufacturing site that interact with the computer systems at UPS for delivering or running the supply chain of that. These cyber physical systems allow the entire production process to be envisioned in one system, but physically happen at different locations. So this is where the data connectivity comes in. When you have physical locations making different pieces of a product, coordination between all those systems is getting higher and higher to the point where we can share we're headed towards being able to share the amount of data you could get from looking to your assembly line on the left to one that's next to you, but now they're actually separated by physical space. And this gives us a lot of opportunities to improve the world, broadly speaking. Coordinating systems across geographic space, so all in one, cyber infrastructure that's calculating what to do and when, can help reduce wasted inputs or taking too much input that can't actually be processed. If you have weather that interrupts some shipment of parts, you can have your cyber infrastructure slow down or speed up production at one place or another. So more efficient uses of resources is possible under this centralized computing structure. And taking better care, having more efficient use of our resources helps us help the environment, make less negative impact on the environment around us. It helps us have positive economic impacts without wasting physical product. And so there is, as you may find passion for things related to the environment and for different human social factors, there are outlets in manufacturing for you to make positive change on the things you really care about. And the mechanism to move through that is by learning the information and empowering yourself to make those changes. A little more on that in a moment. But this isn't a nebulous idea that is purely in the space of universities and thinkers. This technology is everywhere, especially in the Midwestern USA, which has some of the largest manufacturing opportunities in the country. Just looking at Kentucky.gov site, they highlight a lot of different industries: agriculture, automotive, aerospace, food and beverage, logistics, which is like your UPS and Amazon warehouse. There is high integration of technology across all these areas in the state of Kentucky and surrounding Midwest area. Every single person in this Zoom call today could go to engineering school after you finish high school, graduate, take a job in the Midwest in manufacturing, and there would still be a need for more. We have loads of opportunity. And just continuing on this site, I thought I was going to have to personally craft a zippy example of a robot in a field, but that was not the case. Just click the agriculture technology, and the Kentucky website did my job for me in showing a robotic arm working on spraying some plants here. And if I can obviously have a lot of the opportunity to read, as our previous speakers were talking about, the latest innovations in the engineering space. But this is not just at the university and sort of conceptual side of things, but technology is being integrated in the economy right now all around us, especially in the state of Kentucky. One example is in agriculture, using robotics to help support a lot of this large scaling of farming and agriculture activities. Another example is just in automotive the automotive sector of Kentucky. Here's just a map of facilities in the automotive related manufacturing around Kentucky. You'll notice they're pretty much everywhere. So any of you watching from Kentucky, you can probably drive within a few hours and definitely be at some sort of automobile related manufacturing facility. Now, these are all separated geographically, but are becoming more and more integrated data-wise. So you can know that a part being built out in the western side of the state has a spot on the assembly line in the north side of the state being combined with a part from the middle of the state. The connection to data allows these distributed around the state operations to be more effective, both cost effective and environmentally effective. So by supporting manufacturing with your engineering savvy, you're playing a role in shaping the way our society exists and moves forward, because as we saw right at the beginning, man-made objects are everywhere. But it's not just Kentucky where this is happening. You can look at total manufacturing output by state. The Midwest is absolutely holding its own. If you added our Illinois, Indiana, Ohio, Kentucky, Tennessee, add us all together, we can even hit higher numbers in Texas and California, which huge land masses there, but they have massive output as well. So the Midwest has a ton of opportunity around every corner, as Mike Norman was saying at the very beginning of this summit. Within 2 hours of where you live, there is most definitely an opportunity in a science and technology related field. The scope isn't just related to the Midwest. I just wanted to highlight the scope of the change of data in manufacturing is not only regional, but impacts governments at the state, at the country level, and even at the global level, as we have interconnection of manufactured goods from different countries overseas. There are huge societal impacts in how do we provide training and help workers have opportunities. How do we design what the jobs of the future are so that people feel respected and have an identity that is a positive view of what they're doing? Give them a work condition that is respectful of themselves as a human. As we push into this Industry 4.0 realm, these are considerations that have to be in place so that humans work well alongside the technology infrastructure and are not simply plugged into things that we can't get robots to do. We need to make sure we highlight and really bring forward the parts that humans can do better than computer systems, while respecting the individuals that are doing that work in the types of work that is done. So I mentioned a few examples just in Kentucky, and there are a number of different industries that could be impacted. A few more examples in agriculture, for example, using sensors and data collection to monitor crops and fields. You can use drones to precisely target application of fertilizers or insecticides, rather than just having your plane spray your entire field. Maybe you only need 1/8 of the amount of fertilizer than you would have been deploying otherwise. Again, efficiency gains, environmental impact, all wrapped up in this idea of technology and manufacturing. In the realm of quality, you're gaining efficiencies on factory lines by being able to analyze mass sets of data to determine if you're producing goods that are up to par or not good enough. On the supply chain end, especially over the last few years, there's been a lot of strain on the supply chain as we go in and out of pandemic-related shutdowns. And so certain industries have dried up in being able to get their raw materials, while others have been okay. Supply chain data logistics could be used to more equalize the way goods are manufactured, so you don't have factories waiting for something that is stuck on a boat for 5 months. You can more evenly spread your resources and make more efficient use of everything you have available. In retail, we've all been exposed to the movement of cashier human checkouts to smart checkouts, and that has a lot of implications to the businesses and how people interact. with the product. Healthcare benefits a lot from being able to look at large data sets, but even at the most minute level, you as a person have a data history associated with your health. If you've ever taken a medication, and having a historical record or a data record of that that can move with you to your doctors allows your doctor to make more educated healthcare choices when working with you. And then in the realm of energy, we're all familiar with the prevalence of electric cars becoming more and more as we move forward. Our power grid, when it was brought into being, was not prepared for the types of loads and the high usage of loads that we put on it today with electric cars and air conditioning units in every home in every city, and high energy manufacturing situations. And so data and Industry 4.0 is also envisioned to help support our existing energy grid, which is over 100 years old now, to move more towards a smart grid situation where maybe the electricity for the neighborhood that you live in is all being generated, but maybe it's being stored and moved around between everyone in the car, in the neighborhood's electric vehicles. They can absorb some of that energy at night and distribute it during the day while saving enough for your commute to work or school. And so there are a lot of opportunities where for in energy that need to be addressed as we become more and more energy hungry and move away from, to some degree, fossil fuels, although while energy is becoming much more prevalent, that's not disappearing at this point. And so you have all these advances possible being envisioned. Who comes up with these systems? And that would be engineers. There are many types and specialties. If you search any given university around the country, you'll see many different types: mechanical, chemical, electrical, biomedical, agricultural, many, many, many more. As our first speakers noted, engineering is becoming more and more highly collaborative. So if you are an electrical engineer, like I was when I was in school, you will be working with mechanical engineers and chemical engineers and biomedical engineers to make the products you need to make. Because the siloed form of maybe traditional style education is rapidly shifting to collaborative models where we need multiple disciplines together to actually solve a problem. And the topic knowledge is not all you need. And these future-ready skills you may have right now or you're working on right now. Maybe you've been working on them your whole life, but being eager to learn about new technologies. Our first speaker said, you have a rapidly changing technology space. I completely agree. And the eagerness is a future skill set that you're going to need. Being both a team player and leader allows you to flourish and thrive in collaborative environments. And you've got to have that creativity and originality. For the challenges we face today, we need creative thinkers to push forward new solutions. And so where I wanted to go towards at the end here is, how do you actually get into this nebulous space I've been describing of STEM careers related to manufacturing? We've noted they're available everywhere. After your middle and high school experiences, you will need additional training to move you in the direction of engineering. But that can take a lot of different forms. Within the manufacturing engineering workspace, you have many folks with an associate's degree, which is a 2-year degree program, and then many as well with a bachelor's degree, a 4-year degree, typically from a university such as the University of Louisville or Kentucky. But there are many other around the state as well. And then the higher degrees, of course, playing a part in that as well. But choosing what to do after your high school experience really requires some soul searching. How do you want to get into industry? Do you want to get a shorter degree and then grow while in the business? Or do you want to spend more time in school, jump into the business at a slightly further on level based on the education you've received? I invite you to go Google promotion path from technician to CEO there. typically most companies have a way for anyone at any technical level to work their way through any company. And when I say work your way through the company, it can sound kind of grueling. But what I mean by that is you are picking up new skills as you participate in the workforce. And at a certain point, you know enough that it's really beneficial for you to tell others about it. As you look around at different education institutions, you'll see different types of engineering related degrees. Traditional engineering education tends to look at more separate subjects in more of a theoretical manner and leans on the right side of that figure towards theoretical research and design and analysis. Whereas you'll find engineering technology programs distributed around the state that lean more towards your active and applied hands-on type of activity. And those folks lean more towards manufacturing and production. But wonderfully, right at the center of both of those is company management. So if you have a great idea and you're ready to change the world, take the pathway that gets you started in a way you're excited about. You could start your own company and use your engineering experience along with your creativity and savvy to push forward the idea that you have. So where to go right now, though? Maybe you're not a senior right on the cusp of choosing some education or trade school or things like that, post high school, which is also education. But if you're not at the cusp of moving out of high school, you may say, what can I do right now? Explore, find out what you like to do, and reflect on why you like to do it. So if you find yourself crafting, if you find yourself taking apart electronics, working with cars, doing woodworking, sewing, knitting, crocheting, baking, I encourage you to do all kinds of different things. Do science at the Kentucky Science Center, whatever it may be. Look at your local area for clubs and communities that are doing interesting things that you may not even know a lot about, but find a meeting happening or see someone doing something cool at the coffee shop and go over and just say, hey, it looks like what you're doing is really interesting. I'd love to hear more about it. You could email professors at a university to hear about the research they're doing. Passionate people love to talk about what they're passionate about. And so finding out more and receiving some of that energy about different disciplines is as easy as making sure you get out there and don't be afraid to not know something. So get educated on the topics you care about, be discerning in the content you consume, but learn really what your passions are and what you enjoy and why. And there are science and technology related opportunities in manufacturing for you. So my final thoughts are advances in technology have brought massive opportunities in the Midwest. And when I say manufacturing, it can evoke an older viewpoint of standing on an assembly line, putting something together. There are opportunities working with computers, doing design work and drafting, doing computer coding, working on artistic renderings and mock-ups and prototyping. So regardless of what you find yourself enjoying, there are ways for you to interact with manufacturing and engineering as a way to support your life and also push the things you care about. We're exposed to a lot of dystopian sci-fi that says the big company exists and we can't affect anything. But if you educate yourself, be confident in what you believe and push forward, you can absolutely make change in the world on the issues you care about. And there are pathways everywhere. So do a little digging, look around you in your local community, at your local museums, find colleges and universities, see what they offer, talk to people, look at certifications and trade schools if you're looking to dive right into the work early on. Find internships, shadowing, on-the-job training at companies that are around you doing work that you may be interested about, or maybe you're not, but you just want to know what they do. Spend a day following around someone there. So I'll leave you with those thoughts. Ultimately, I'm saying it's up to you to really dig in and research what's around you. I can't pinpoint every opportunity in the state, but I hope that you will think carefully about what your skills are and connect some of that to engineering and to technology, because there's a huge amount of opportunity there. So thank you very much for listening to that.
All righty. Thank you, Dr. Lucas. So I am not Veronica. My name is Justin. I'm stepping in for her for a quick second. But thank you, Dr. Lucas, for sharing that. That's an amazing story, amazing timeline, of great perspective on that sort of how fast digitally we move now. It's incredible. So we do have a handful of questions we'll go through. We have about 5 to 10 minutes real quick to go through these. So you talked about kind of bringing, like you said, your passion into engineering. Don't just, it's not just engineering for engineering's sake, but it's so many different fields that go into it and affect it. Someone asked, what are ways that art plays an important part in engineering and mechanical design as well?
Yeah, so that's a great question. And I frequently tell my students, don't lose that artistic passion. And many times my best students are those that can visualize a concept using different colored pencils and are comfortable with color and form. And so art plays a huge role in the design of anything, because to convey an idea from one person to another, there are many ways to do that. Just in words is one option. But we're all familiar with the phrase is a picture, speaks 1,000 words. To be able to convey your ideas in simple sketches and drawings is a core mechanic within engineering. Just conveying ideas from one to another, not only from two similarly trained people, but when conveying collaboratively. If I'm conveying an idea to a biomedical engineer, drawing a picture of what I'm thinking and maybe a picture from their end allows us to communicate more rapidly what we mean without us both having to spend 4 years getting the same degree as each other. Art and the ability that we can connect with each other through art is at the center of engineering and collaborative work in just being able to convey ideas.
Excellent. Thank you very much. So another question we had was, what is a design component or research that you've done that you are most proud of? I think we talked a little bit with the doctors before about some of the projects they've worked on and they're most proud of. What's something maybe you've done related to your field or in engineering, mechanical, or a little bit of everything that you're most proud of?
Yeah, so in the past, as I mentioned, I did a lot of work on implanted biomedical systems. I had done a lot of work with making small scale actuators that could squeeze something at the level of a cell, and they weren't wired up or connected to anything. They could actually be triggered to move just by shining different wavelengths of lasers at them. And so academically, I'm very proud of the work that went into that. In my life, in teaching, the type of scholarship I produce has changed a bit. And one of my prouder constructions is I have a lot of infrastructure that I run in classrooms to highlight individuality of students and allow student-driven projects to exist. So if you find yourself in an engineering program with an idea, you'll find many educators these days will find ways that we can take elements of your idea, kind of intertwine it with course content of the discipline, and really push forward ideas and learning driven by your prototype. So some learning infrastructure is probably most proud. As a product, I've done some really neat implantable micro electromechanical systems in the past.
That is awesome. I love this. This is our last question we have here, and I think this is great because we think about where we've been kind of since 2020 and through the global pandemic, and all of the crazy things that have happened to supply chains and infrastructures and all of the different changes we've had to make. But what are some ways that the pandemic has affected or expedited this digital revolution, digital industrial revolution that you've talked about?
Yeah, so it has definitely highlighted the urgency of working out a lot of the details of what this data infrastructure looks like and how it operates and how human users interact with this system. And so when we all had to go home for 2 years straight, in the manufacturing sector, fortunately for many workers there, they were able to work remotely in many ways, which is a benefit of the sort of the future element of the manufacturing sector. But it also highlighted a lot of issues with remote work, maybe even the work, the structure of companies historically, in the way that we spend time and in the way that we interact with the work that we're doing. So it highlighted that humans need to be more in the forefront of the design of manufacturing systems because they play an integral role in the system in that they run the system. And then second point I would raise is that the data-driven elements that were being implemented pre-pandemic were moving in this direction, but the pandemic era sort of lock-in mechanisms really highlighted how much we did not know and how much we still look to capture from our human senses. If a machine is going to need repairing soon, is it able to sense that somehow electrically or mechanically itself? Or is it the repair technician heard something clicking? And then how do we actually capture something like that if it's going to be a purely remote situation? How do we keep from just leaving our robots in the lurch, if you will, without the human operator there? So it has definitely expedited realizing what we do have and what we do not have and need to develop further.
All righty, well, thank you so much, Dr. Lucas, once again from Purdue, located in New Albany, Indiana, not West Lafayette, Indiana, but right across the river here and at the Purdue Polytech Center. So thank you very much for your time this morning, sharing some of your research, some of your interests, and just amazing inspirational messages too for our young students that are watching. So we thank you very much, and we hope you have a good rest of the week and weekend.
All right, thank you.
All righty, well, we are going to be moving on to our next speaker. We have Afi Tanjdi. And I do apologize if I said that incorrectly. I'll let you correct me on that. But Afi is an undergrad student and researcher at the University of Louisville School of Medicine. She is also the chair of the Young Adult Content Committee and here with Kentucky Science Center, and as well for our Uniquely Human project. So we are installing a brand new exhibit here on our third floor called Uniquely Human. And Afi has been an amazing person to work with us and kind of helping us get some of her research, some of her past, some of her understanding, and some of the things that she's been a part of. So we just want to welcome her to the Kentucky Science Center Youth Science Summit. Afi, can you hear us?
Yes, I can. Can you hear me?
Yes, I can. All righty. Well, we'll let you take it away.
Thank you. I think I'm having issues starting my video, but. Oh, I don't have video access. If you could grant me that.
You have just been made a co-host.
Awesome.
There we go. All right. Thank you.
Can you all see me? Yes, I hope so. Awesome. So hello, everyone. My name is Afi Tanjdi. I am currently a senior undergraduate student at the University of Louisville, but my research is on the health science campus with the University School of Medicine, specifically the pharmacology and toxicology department. So I do breast cancer research. It's so great to be here with you today and really excited to tell you a bit about myself, the work I do with the center, my interest in research and science, and hopefully hear some of your perspectives on what is it that draws you to science and what it is that are the most pertinent issues when it comes to young adults, when it comes to engaging with science and sort of the disconnect between science and society. So as I'm giving my talk, definitely feel free to type in any questions about, college, how I got into research, my personal life, anything. I'm happy to answer all those questions. So yeah, to begin, again, I'm Afi, originally from Togo, West Africa, came to the United States in 2015, went through high school, and then currently at the University of Louisville. I study biochemistry, but I'm also a math and peace, justice, and conflict transformation student. I was recently named one of the Goldwater Scholars. And so my interest really is in actual pharmacological research when it comes to cancer. On the other end, which is the Kentucky Science Center, I am well engaged in the larger Louisville community, and my passion and focus is really centered around the disconnect between science and society and what role scientists and individuals like that can play in it. So at my heart, I say I'm a researcher, but I'm also a people person first. And I think one of the most important and most relevant things that you can think about as people who are looking to go into science or as young scientists is how is what I'm doing affecting the people in my life? How is what I'm doing connecting to the people around me? And which is why I was so excited to work on the Uniquely Human project, because it is this thing about a better we and a bigger we, where we focus on the role that science plays in individuals' life, right? So I always think science is a means for us to understand the world and for us to navigate the things around us, right? The things that we may not understand, use inductive reasoning, conduct research, understand it better, navigate the world better, et cetera, et cetera. And I also think one important thing that comes to that is coming together and having conversations about what are the larger needs of society and how can we as scientists and people who are interested in science or learning science do that, because it really is a privilege to, have access to certain information and be able to figure out and research certain things. So yeah, that's just the general gist about me. But with the Kentucky Science Center specifically, I work with young adults. I'm chair of the Young Adult Content Committee for the Uniquely Human Project. And this is really where I want maybe most of our focus and questions, et cetera, to come from. And definitely let me know if there are any questions. I'm happy to answer them as I go out. I'd rather this be more of a conversation than me going on like a full-on lecture about the things that I do. So first, the Young Adult Content Committee is focused on sort of bringing youth voices and youth perspectives, which is really, really relevant to the scientific space because, as you know, or you may have experienced yourself, oftentimes young adult voices and youth voices are sort of like ignored when it comes to larger impact on society, because we're really not at the place to be in the positions of power, in the places where the biggest decisions are being made. So the goal of this committee is to close that gap a bit and make sure that it is actually the young adults that are designing the content and putting in the input for what the Uniquely Human project is meant to be. And I think a lot of times when people think of the Kentucky Science Center, they think, younger kids doing science at play and all these things that are sort of targeted at younger demographics. But with the Uniquely Human project, the hope is that we're catapulting out of that and engaging a more older audience, which is sort of you guys. And I say you guys as if I'm not a part of you, but engaging a younger audience and sort of connecting with people who are going to be the next step in what the scientific community look like, the next step in what the leaders of our own community look like, right? And so when I say science, I know STEM comes to mind, the pure sciences come into mind, but I also mean the social sciences and arts and just science broadly speaking. And so I think it's integral that all these parts and all these things work together and come together for, the success of humanity. We need to move society forward. And I don't know if you guys always know this or this is something you all notice, but progress is not always positive, and it really is a commitment that you have to make to moving things forward in the right direction, so to speak. So yeah, I am super happy to hear about any questions you might have about the college experience, the work I do at Uniquely Human, how I got into research, anything. I want to talk about what you guys want to hear. So yeah.
All right. Well, we do have a few questions here. So you mentioned you are studying biochemistry.
Yeah.
Talk a little bit about your favorite part about that and what drew you to that specific type of field.
Awesome. I think so. I grew up in Togo, West Africa, and it was amid a time of like civil unrest, conflict. So not a really peaceful time when I was growing up. And because of that, I had to move a bunch of places and didn't know the language, etc. And so for me, science was really a way for me to communicate, right? A language that people everywhere understood. And so I sort of clung to that. And when I began school, it just came much easier. And I was more excited about the scientific concepts than anything, because for me, that became sort of like a hope and a way to not only make people understand me, but also understand the people around me. So that's how I came to science, broadly speaking. And, just experiencing health disparities and firsthand, and also learning about it made me realize that, my scientific pursuits, no matter what direction they go, would definitely have to do in health in some way. I came to biochemistry because I'm a bit of a nerd. I love organic chemistry, and I know my friends give me a side eye whenever I say this, but I teach organic chemistry here at the University of Louisville also. It's called a PRIMES program through the National Science Foundation, and it's just something that gets me excited. I think one thing that's really important to keep in mind when deciding what your major is, deciding what to pursue, is what feels incredibly right. It's not like, what's going to make the most money, what that's pleased my parents. I know that's a big factor, especially when they probably are the people paying for your education. But it's more important to go in the direction that feels incredibly right. And for me, that was when I was in the lab. So when I'm in the lab, I'm pipetting things, organizing, designing experiments. I feel the most me and the most comfortable. And I really enjoy all the people that I work with. I like the idea of having something that's project-based. And so if I design an experiment, I'm seeing it through from start to finish. And I'm sort of the main person, gathering information. And then when I find my results, I get to present it, discuss it, share my ideas, communicate that with other people. And so first it started as, this is really the only thing that feels right. But as I'm growing, I've come to develop a sort of love for the field and what it has to offer society, broadly speaking. I think biochemistry, it's a really, really good topic of study if you're interested in the human body, as well as what happens on the subatomic level and chemical level. So yeah, that was a really long-winded answer, but I hope it gave all the information that you needed.
No, that's great. That's exactly the kind of answers we're looking for. That's very thorough. Thank you very much. And I think someone was kind of trying to remember, what were the other studies that you are also doing as well as biochemistry?
Yeah, so I'm studying math. So just regular mathematics. I enjoy calculus. I think it's very intuitive. It's one of the better maths, in my personal opinion. Some of my professors disagree, but yeah, I think calculus just like, if calc is hard for you right now, I definitely encourage you to give it a try when you get to college. I think instructors that can teach really complex topics in a very intuitive way just make everything so much better. And I have found that here at the University of Louisville. So I enjoyed my time in calc. So I'm having math as one of my minors. And then I'm in peace, justice, and conflict transformation. And so that's really learning how to navigate conversations, how to engage in really difficult dialogue, and how to be a sort of mediator when it comes to certain conversations and certain topics. So that is actually part of my scholarship program. I'm a Martin Luther King Scholar here because I like to have a community-focused and a justice-focused approach to whatever science I'm pursuing. So, yeah.
So what similarities do you find between those two studies? Now, obviously, math and biochemistry, you probably see very obvious relation with that. Yeah. But, your studies with peace and justice and that dialogue, you find sometimes when you're in biochemistry, you're learning something biochemical related, and you're like, that kind of relates to what I'm also learning in this other class.
Yeah, I think I mentioned inductive reasoning and deductive reasoning earlier, but I think the biggest thing a college education can offer you is the ability to critically think, right? And those are things that are transferable no matter what field you're in, no matter what area you're in. So the skills that I've noticed in my mediation classes, for example, of picking up on tiny details, noting tone and noting just the mood, et cetera, of someone are really applicable when, for example, I'm reading a research paper and there may be some connotations that may not be really clear. And I'm like, oh, the researcher wrote this, but maybe this is what they were thinking about at that time. And I think that's really, really important and a really relevant skill to have, because a lot of scientific document can be really technical, but when you can read meaning from really technical documents, it adds a little bit of flair, a little bit of flavor, and you can sort of enjoy it as you go along, right? Just as one of the little perks of that. Another thing that transfers from my biochemistry and math to peace and justice and conflict transformation is the understanding of like categorizing things. So one of the biggest things in science, I'm sure you guys have already learned about, you know, the major biology and cells and la-di-da-di-da and all those things that come with it, properties of like parts of the cell. But through categorizing function and understanding, even with chemistry, how electrons move, and how that is basically the foundation of all reactions. So understanding fundamentals that sort of run things is also really transferable to conflict and justice transformation, because if you can pinpoint the source and like where a lot of people's emotions and reactions to things are coming from, then from there you can extrapolate basically what they really need in a particular situation that they may not be communicating as clearly. So yeah, science, that's why I said science broadly speaking, because this applies to everything and it goes everywhere. So yeah.
Excellent. Thank you. That's a great answer to that. So what do you, let me make sure I get this question right. What do you want to accomplish with your studies? So what is like maybe an end all goal? I don't know if it's career wise,
Yeah.
or maybe it's just a project or something that you want to accomplish when you kind of get done with, you know, the studying and the research aspect. What does that next step look like?
Yeah, so I'm currently preparing for my MCAT. Direct future is probably medical school, but I'm looking to take a gap year, hopefully under a Fulbright scholarship, but maybe in industry also, depending on how, you know, applications and stuff like that go. But there are a few possibilities in the future for me, whether it's pursuing a direct PhD, an MD PhD, which is doctoral training and then PhD training combined together, or just a medical school degree. I think I'm more open to going with the flow of either things. But broadly speaking, project-wise, like you mentioned, I would love to diminish morbidity and mortality rates when it comes to cancer, especially with the types of cancer that most affect Black and Brown communities. And so for me, I mentioned earlier, having a health disparities approach and a health disparities focus to the type of research that I do. And all that is, it's the communities that I hold dear and the people that I see around me every day, right? And hoping that I can make a difference and an impact in their life. My dream, big science dream, is hopefully I win a Nobel Prize someday for the type of work that I do. But that's just something I put like at the very top of the hierarchy of my scientific goals. But for me, I will be very content and very proud and fulfilled if the work that I do, no matter as a PhD, an MD PhD, or a researcher or someone in industry even, if the work that I do impacts the people that I care about and the people who look like me and the people who live the life that I do. So for me, that's Black and Brown communities and people who have experienced cancer or are going through very harsh sort of treatments. If there's a way I can make a difference in that capacity, yeah, I'll be very, very fulfilled, very happy.
That's amazing. Yeah. And I assure you, everyone on this call wants to see you win Nobel Prize as well. I would love to be a Nobel Prize winner. That would be amazing. Okay, so let's see here. So you mentioned how when you're going into science, what you're doing affecting the people around me. That's what you said you should ask yourself. So what, when you have asked yourself that question, what is what I'm doing? You talked a little bit about that with what you kind of want to accomplish, but what have you found to be the answer? How is what you're doing affecting the people around you? Have you started to see some of that kind of?
Absolutely.
Great.
Absolutely. Beyond the day-to-day interactions, right? I have this whole principle. It's probably my mom who instilled it in me, and finding meaning in the day-to-day interactions. So the people that I work with whenever I go to hospitals and we're visiting people or interacting with a patient one-on-one and having those conversations. A really simple example, which is really not so simple, is I was in an R25 program, which is a cancer education program. And when we're doing research, we have a discussion about sort of like, the impact of our research and meeting people who were experiencing the type of cancer that we were researching. And when I was having conversation, I worked on triple negative breast cancer cell lines, which are really predominant in Black communities, really aggressive, really hard to treat. And so that's sort of the focus of my research during that summer, and has been for about 2-3 years now. now. And I met with a bunch of like African-American women who had gone through the same type of cancer, the same type of treatment. And we're just having conversation about things and little nuances that maybe their doctors didn't understand. And so one of the stories that I'm going to keep with me forever is me having a conversation with one of our mentors that, hey, it's really interesting seeing the difference between how Black women and, you know, other women of color and even white women decide on what type of treatment they want to pursue when it comes to breast cancer as a whole. And we're having a conversation about Black women being more scared and more worried about losing their hair and would rather go on with like full-on surgery than certain types of chemo that will cause them to lose their actual hair. And I think that just having a conversation with the patients and having that connection of hair is really significant in the African-American community. It's a huge part of identity, a huge part of like how you present yourself and sort of your pride in who you are and where you come from. I wear my hair natural. And so just having that sort of personal connection, I see that there, but also in the larger impact. I just published an article from a Journal of Pharmacology and Toxicology, but you can just Google it on like PubMed or Google Scholar on upregulation of cytidine deaminase in triple-negative breast cancer cell lines. And that was sort of the big product of the research that I've been working on for the past 3 years. And hopefully with that type of result and information that I found through that research, we can have more targeted approaches to, you know, cancer broadly speaking, but specifically triple-negative breast cancer cell lines. So we're hoping that there will be combination therapies that will make quality of life better and higher for people who have those types of cancers. And so, yeah, just from the personal and communal to the larger and, you know, scientific approaches that and impacts that, you know, I may not be aware about, but the hope is that information that I've sort of put out there is going to help someone figure a way to make treatment better and make chemotherapy much easier, make someone be able to, you know, go back to their family and their kids after they've experienced a treatment and not be bedridden forever, basically, and, you know, have something to look forward to every day beyond laying in bed because of how strong or really damaging treatment is to quality of life. So yeah, that was a really long-winded question and it went in very direction, but I hope that sort of got to the question you were asking.
Oh, it definitely did. So I have someone who's asking, what is uniquely human? You know, I know we kind of touched on that a little bit. I mentioned a little bit. You talked a little bit about your work with it. As someone who works here at the Science Center, obviously I am a little bit more familiar with it. It is going to be an exhibit that we'll be installing on our third floor in the coming about 3 or 4 months. Hopefully, that's the plan. We're working on that. But I'm going to kind of add to this question as far as not just what is it, but what if I go to this exhibit, what am I going to walk away with?
Yeah.
What am I going to be? Am I just going to be reading panels like a museum exhibit?
Absolutely.
Yeah, absolutely not. So I'll let you touch on that a little bit. What if as a visitor, if I'm going to this exhibit, what am I going to walk away learning or being affected by?
Yeah, so the goal of Uniquely Human is that after your gallery experience, you're walking away more understanding of who you are and what your beliefs are, and also finding better ways to connect with the people around you, right? So the whole project and understanding of Uniquely Human is that there is this bigger we, which is we as humanity, that, you know, we're all unique in our own ways. We come with our own beliefs and perspectives, and we all love science, right? That's sort of the assumption that we're having when you're walking into Uniquely Human in some way or some capacity. But also science, broadly speaking, because there's also social sciences, right? So we want to understand the community that's around us, right? Racial justice, conversations around health equity, conversations around access, conversation around poverty, conversations around quality of life, the economy, etc. All coming together in this like cumulative experience of this is what makes a person, this will make them special, and this is what, you know, makes them unique in their own way. We're hoping that the exhibit will also offer interactive experiences experiences. So a lot of like really high tech stuff, but also personalized experiences where you're walking and maybe you're sitting down in like one of a workshop room and you're having a discussion about, you know, what is the most prevalent issues in our community? How do you support other youth? How do we target and navigate this mental health crisis that is affecting the younger demographic really significantly, right? How do you pursue school or find your passion again after the pandemic has sort of put a hinge in that? And so the whole goal of Uniquely Human is to offer a cumulative gallery experience that's super high tech, but also have that personalized and community aspect to the conversation. So you can understand science and see it in all its facets. So I'm really excited for a lot of the things that are going to be installed in the exhibit. The opening is going to be probably in June or like July, so summertime. And there are a lot of things in the exhibit that the Young Adult Content Committee sort of really pushed forward. And I'm hoping that you guys will be able to experience that and be like, oh, this is really relevant to our time, relevant to people our age, and also really impactful, something you can take with you. So, yeah.
Awesome, thank you. Yeah, I know I'm really excited for that exhibit to be installed and opened, and just see, like you kind of touched on with what the exhibit is. It's not just exhibit here at the Science Center, but it's an exhibit that has a community impact.
Yes.
Community presence, and not very many science centers and museums have exhibits that can do something outside of their building in such capacities and send people away with that sort of understanding and feeling and messaging that we hope that it does and that it accomplishes. So thank you all for so much. Thank you so much for your work in helping us develop that and the research you've done that's gone into that. So we have a couple more questions here. You talked a little bit about making, let's see. Okay, so we want to try to use science for good. You talked a little bit about using the scientific process, and sometimes progress is not always good, is what you said. So how can we use science to make progress good? That's with that.
Absolutely. And that just touches back on a few things that I mentioned earlier. And I say this all the time because it's sort of a misconception that, you know, if it's technologically advanced, if it's, you know, looking to the future, then it's good for humanity. And I don't think that's necessarily true. And I think the way you can use science for good is putting people first, right? So whenever you're pursuing any scientific endeavors, whether it's in industry, in engineering, in math, and whatever field it is that like you are into, or you find your passion in and hope in, I think before you design any project or you continue with any type of research, think, who is this going to impact and how is it going to impact them positively, right? What are the society's biggest problems and how do I work towards a solution like that? And I know it can be some sort of sometimes daunting and really difficult to sort of conceptualize a lot of those things. But if enough scientists can think that way, then we're solving the problems of now rather than solving imaginary problems or possible problems that could be, right? As relevant as those are, we still have poverty, we have famine, we have massive droughts. We have major health disparities. We have major lack of technological access around the globe, and many other problems that like are persistent and to day, right? And so if you can find a little niche of that, of whatever those bigger problems is. And for me, the easiest way I can do it is looking around me, looking at my community, seeing what do they need and what passion do I have that aligns with the solution for that problem. And for me, that was science, that was research, that was medicine. But for you, it might be different. So looking at the people around you, seeing the problems that they have and seeing what passion of yours you can use towards a solution. I think that's a really, really significant approach where you know you're positively impacting at least the people around you. So you know some good is going to come out of that. So, yeah.
Yeah, that's so true. I mean, there's going to be problems of tomorrow, but there are problems of today that become bigger problems tomorrow that we are definitely trying to figure out right now. That's so true. Thank you very much. All right, so the last thing I have here is a final question. Any last advice you give to some of these young people as far as going into college, trying to find something maybe they want to focus on or move forward with, and then, you know, how do they kind of keep going forward? How do they stay inspired maybe a little bit of that? Wow.
Yeah, I know I've talked about more ideological solutions. I'm going to speak to some things that may be a bit more concrete. So first thing I would do is to visit the colleges or the high schools, etc., that you are interested in, and meet with the people. Try and schedule a personalized visit. Almost every university and almost every high school offers this. Tell them what your interests are and be like, I want to meet with students who are doing what I'm doing right now. I want to meet with professors who are teaching what I, want to study someday. And that could sort of give you a feel of, is this a space I want to be in? For universities, I would encourage you to, shoot for the stars, be sort of aggressive in your approach to like find the best option for you, but also choose a place where you feel like you care about the people who are around you. Out of state is the best option for some students, and in-state is the best option for other students. I wouldn't say just like discount one over the other. I chose University of Louisville because it was an R1 institution, and which is Research 1 category. So I could do as high level research as I wanted, had access to all the hospitals because the University of Louisville owns almost all the hospitals in Louisville and has like other branches elsewhere. And it also has a really big immigrant community, and I'm an immigrant myself, really big Black community that's also very involved in health equity. And that's something that I'm passionate about. And so look for those really tangible things, because more than your classes, what's going to keep you inspired and keep you going is the community around you. And if and when you get to college, or if and when you get to the high school, find your people. And it's okay if they grow and change and your people look different by the time you graduate. But if you can have people around you to hold you accountable, support you when you're not doing your best, motivate you when you're trying to push for something, and cheer for you when you reach those milestones and have those accomplishments, if they'll be your sort of your biggest cheerleaders, and vice versa. And I think people are most important whenever you're deciding to go anywhere to spend the next however many years. And I think more than just resources, and I know resources are really relevant, it's important that you realize that, in your own abilities, you can do whatever you want anywhere, as long as you have the people to support you to do it. So yeah, that's more tangible approaches and stats for you guys.
Excellent. Well, I really appreciate that. Well, Afi, thank you so much for joining us today. Thank you for being part of our Youth Science Summit 2022. So we hope you have a good rest of your week and weekend. And thank you. And I know I'll probably see you around here as we get human stuff. So I'll be sure to thank you then as well. But thank you for all your encouragement, all of your lessons, all of your insight, and advice for young people listening.
Awesome. Thank you so much for having me. And I hope you go do science and do it awesomely. Thank you, guys.
Awesome.
Bye-bye.
All right, great. Thank you. Bye. Okay, so I just want to touch real quick. Again, just to remind everyone, thank you so much to our sponsors to make this possible. Lexmark, Toyota Kentucky, and Kentucky EPSCoR. Those are our three main sponsors for this Youth Science Summit in fall of 2022. We have had a amazing Youth Science Summit, heard from amazing speakers, talked about some of their amazing work. And we are going to move on to our final speaker, Jordan Bays, who I'm going to kind of read through his bio here. So Jordan Bays is he's the CEO and creator of Jordan Bays Solutions, which was created in 2011. Is an organization that helps kind of work with creating bold presences and works with companies that are already established and up-and-coming companies to kind of get them up on their feet, consulting with them. He's also in conjunction with Bays & Sons LLC out of Bremen, Kentucky. It is a Kentucky-based lumber manufacturer that is a family-owned business for the last nearly 7 decades. That's incredible. So I know we're going to hear from him a little bit about his work, a little bit about his own life, some things he's done, but also a little bit related to his lumber business. Because when we talk about doing science comes in many, many different ways and many factions, and that includes maybe working out in the field with lumber. And so we're going to maybe hear from him kind of what that looks like. But Jordan, thank you so much. Jordan also is a great friend of mine. He and I got to be a part of a Leadership Kentucky class. So he and I got to meet up from that, and just hearing his story and the amazing work that he's done, it's amazing. So I let you take it away, Jordan.
Sure. Thank you so much, Justin. Pleasure to be with you this morning. Been looking forward to this opportunity to speak to you guys for some time. It's been a great morning so far. I feel underqualified, though, if I'm being honest. I mean, we had the heart surgeons and then the college professors, and then here I am talking about lumber. But as Justin said, there is a science to what we do. So I want to share a few slides with you, and then we'll have some time for questions as well. I'm going to try to share this screen. Let's see. There. Well, I think I'm sharing the screen. I'm trying to. Let's see.
Might take a second to load here.
We might should have tried. Are you seeing it now, Justin?
Not yet. You should be. You are set as a co-host, and you should have screen sharing capabilities.
Okay. Oh, I think I just. Zoom will not be able to record the contents of your screen until it is quit. That's not good, is it? Well, I can. I had a short video that I was going to show, so that's kind of imperative, I think.
Well, if you want to try to keep pulling that up, you can also try to email it to myself, and we can see if we can get it pulled up on our.
You want to try to do that?
Yeah, you can try to do that, and then I'll kind of let you keep talking a little bit about yourself, and I'll work on getting that pulled up in the meantime. All right, so we're going to let Jordan kind of get that situated. Once again, kind of talk a little bit about, so we have been able to do our Youth Science Summit days for the last probably 2.5 years. We have representatives from a lot of different places in Kentucky. I believe we have Henderson, Shelbyville, a number of other cities, a couple of Louisville schools. We kind of helped kind of try to spread this outside of the state of Kentucky. So we have visitors from Ohio as well as Rhode Island. So tell you a little bit about Kentucky Science Center as Jordan gets joined back on here with us. So Kentucky Science Center is located in downtown Louisville. We are one of the pretty much oldest science centers in the state. We are the state science center representative. We have 3 floors of exhibits, 50,000 square feet in downtown Louisville. We've been in existence for over 152 years. As in some sort of entity, started out as a cabinet of curiosity with the local library. And have kind of moved all the way until about 1977. We moved into this building here. All right, looks like we got Jordan back with us. We can try to get him pinned and up.
I'm on, Justin.
Okay.
Now it's saying I can't start video.
Let me make you a co-host here again.
Okay.
All right, now you are set as a co-host. Go ahead and try that again.
Oh, great. And I think
Hey, there we go.
we're okay, great.
We're working.
Great.
Yep.
Yeah. All right, great. All right, let's do this. So sorry for the delay and the trouble. But again, my name's Jordan Bays. I am the 4th generation of our family's company, Bays and Sons. And so Justin and I are good buddies, and he asked me a few months ago now if I would mind presenting today. I've been looking forward to it, and so thank you guys for the opportunity. Want to talk about what to some might seem like a very primitive industry. And I guess in some ways it is with regard to its longevity and how long we've been doing this, just as a method of work and as a means to production. But so have a few things I'd like to get to today. Got just maybe 20 minutes or so, and I want to just briefly discuss our company history, where we are now and how we got there. Then I want to talk about, this is an important one to me, the manufacturing process. I'd love to get to explain to you guys how we do what we do, and then what products we make with the timber that we harvest. And then lastly, I'd like to spend a bit of time talking about the perception of environmental harm that the industry has on the environment. And I'd like to take some time to rebut that perception. And I would say, just before we get there, it's perfectly well-founded. You'd have every right to have that point of view, but I hope today I'm able to at least sway that a bit. So without talking too much, we'll get into the history of our company. I love this line, and when anybody tries to ask me what we do, this is how I always start the story. In 1955, my great-grandfather, Jesse Bays, bought a team of mules, that's 2, and a chainsaw, and began harvesting timber from the forest here in Kentucky. You cut the trees with a chainsaw. Back in those days, you did. And then a team of mules literally drags the timber that you cut in the woods out toward a landing site to be loaded onto a truck. That's how primitive it was back in the day. Back in those days, the cut timber was then put on the back of a truck and then delivered to area sawmills for sale. And then just a few years later, 1958, my grandfather and his brother joined the company at the ripe ages of 10 and 12. They made $2 a day in 1958. But the family bought a portable sawmill. So they were able to deliver that sawmill to the woods, to the forest they were working in. And the logs that were cut were manufactured, were sawed there in the woods themselves, so they didn't have to freight the log out of the woods. So that happened for about 30 years. And then until the early 80s, and then the family purchased a tract of land and bought a permanent sawmill that they could have fixed inside a building. And the goal there was to increase production. You know, the portable mills were great and handy, but they weren't really mass production machines like the permanent sawmills are. The ones in the woods ran off of diesel fuel, whereas permanent sawmills run off of wired lines and electricity. And so it's just a bigger process. There can be more volume that goes through the portable mills. And in these days, here's a picture of a more modern sawmill. These days, we have 2 circle mills. Our company operates 2 circle mills. One of them is in Grand Rivers, Kentucky. That's in the extreme western portion of the state, there by Lake Barkley and Kentucky Lake. Then we have a second sawmill in Morton's Gap, Kentucky, just south of Madisonville, Kentucky, both of which are in the western portion of the state. We also have a mobile logging crew that still harvests timber, just like we did 67 or 8 years ago, and a fleet of trucks to move the logs and lumber to their needed locations. So we've come a long way. The process looks a little different than it did, 7 decades ago, but we're still making the same types of products as we were back then. Okay. So here's a little bit of the process. Not many people get to see what it looks like to harvest timber or to manufacture lumber. So I thought I'd show you just a couple machines. Let's see, here's the one I wanted to show you. Yeah, this is what's called a feller buncher. And as you'll see just in a moment, it can cut trees, it can cut timber at an alarming rate. Now, if you're getting tears in your eyes because of deforestation, just hang with me about 10 minutes. I promise I'm going to alleviate your concerns. But with regard to the manufacturing process, this is what it looks like. This big feller buncher has a disc blade at the bottom of that head there that attaches to the trees. It grabs a tree and the disc saws it off at the stump. And then I think here's a great video of it laying the tree down, if I'm not mistaken. Yeah, right there. And so it really can cut timber at an alarming rate. Now, then what happens is they pile the timber. And then what's called a forwarder comes and loads. There's a video of a forwarder, and it loads the cut timber on the trailer behind itself. So it kind of loads itself as it makes its way through the woods. And then so it'll load itself and drive itself to the landing site where the trucks would come in to be loaded. So this is obviously not road illegal. It's made for hilly, woody areas. So we're going to load it off of this onto the ground. And then the next step of that process is what's called a knuckle boom loader. So would be the landing site where the logs would be brought. And this knuckle boom loader, as you'll see, now it's going to move the trailer because the trailer is just a little too close to itself. Now, we're going to sort these logs in different piles based on their species. Like this is probably, I don't know, maybe 30-foot pine that they're moving right now. I think that's what they're going to load on these trucks. That's shorter pine there, the pile right next to the truck. But they're going to load these trucks with specific logs. So these logs might be sold to a pine mill. Okay, we don't deal in a lot of pine, but we run across a lot of pine in the woods. And then I saw some oak logs there. Those logs might be something we would sell, we would bring to our own sawmills, but we might sell this pine elsewhere. But we sort them here at the landing site based on species, grade, quality, length, even, and size. So depending on the length and size, we would sort them differently. So this is an example of a knuckle boom loader loading the truck. I'm going to skip to the end here because it's a pretty long process. But there is a truck that's pretty well loaded. He might put a couple more on there. And now I would say this too, for anybody, I know a lot of folks have fears of seeing logging trucks on the road, and that's fair to say. But when done legally, it's very, very safe. So what's going to happen next is straps will be thick nylon straps will be thrown over the top of this truck in various locations to hold these logs in place for transit. So it's a pretty safe process, and we have to meet all the highway laws that every other type of freight truck would have to meet. So I would venture to say it's as safe as most transport trucks. And then here is a video, and I want to show you most of this. I'm going to leave the sound on this just because it is such an excellent video. I thought I'd go through the entire process myself, but this video was great, and I thought I'd just share with you this video, and then I'll meet back up with you as soon as it's over. It's about 7 minutes long. And would somebody there from the Science Center, would you let me know if we're having trouble with the audio? I think you should be able to hear it, but just let me know if not.
Yeah, we'll let you know.
Each sawmill business is similar in what they do, but different in terms of size, configuration, production output, and efficiency. Every mill has its own locale, species and log size mix, personality, and quality. A significant average-sized modern hardwood sawmill today might employ 15 to 25 people and produce 5 to 8 million feet of lumber per year. Most are small family-run businesses. The supply of logs is one of the mill's biggest challenges. Competition, weather, and shifting market conditions all play a steady role. Mills may need to reach out 150 to 200 miles or more for their logs.
Oh,
Weather and shifting market condition logs. It takes both good cash flow and a strong inventory to keep a mill running efficiently year-round. Mills often employ their own timber buyers who work full-time, knocking on doors or going to bid sales. They also buy from producers who buy timber and often have their own logging crews who produce logs that are sold to regular customers. Every day, log trucks roll into the yard to be unloaded, sorted and measured, and inventoried. There are various grades and species of logs, all with different values, markets, and customers. Important decisions are made about quality and grade as soon as the logs arrive. Veneer is the highest grade and sold to veneer buyers who visit the mill regularly. There are several grades of saw logs that are cut at the mill into lumber. The lowest grade logs are sold to pallet manufacturers and are not cut at the grade mill. To determine value, the log yard manager will note the species, measure the diameter of each log, look for defects, straightness, and heart content as he inputs it into the inventory system. Logs are then placed in their respective areas on the yard by species or quality. The mill manager keeps a careful eye on the age and condition of his log inventory and makes cutting decisions accordingly. In hot weather, mills try to keep lower inventories as logs degrade quickly. Fall and winter act as a refrigerator for inventories, so logs can accumulate and sit for longer periods. Some species, such as maple and hickory, stain and degrade quickly in hot weather and need to be processed immediately. Others, like red oak and cherry, are more resilient and can remain on the log yard longer. As it contains such the saw blades in the mill. Bark that is removed is ground and sold for landscaping material. There are many saw blades that need to be maintained throughout the mill. One of the most important departments at the mill is the saw filing department. Here, the saw filer maintains all the saws for the mill, which is critical for mill performance, yield, and the appearance of the final product. There is an art and science to this particular job at the mill, and it takes an experienced filer to keep a mill running efficiently. Logs are then conveyed to the head saw deck where they are placed on the carriage. Once in place, technology is used to scan the log for its size and shape. Linear positioners adjust the log precisely on the carriage for the head sawyer, who then begins to open the log by taking boards from all four sides down to a manageable size for the resaw. Slab cuts and jacket boards are removed from the outside of the log to create a square, four-faced camp. Slab cuts are sent to the chipper as they have no lumber value. Jacket boards are the first grade boards and will be sent to the edger as they usually contain a lot of wane. Wane is bark or lack of wood. Once complete, the squared log or cant is conveyed to the resaw and another log is quickly reset on the carriage. Any waste material is conveyed to a grinder, where it is made into various products, such as chips for energy plants or core material for fiberboard. Nothing is wasted at the sawmill. Mills that have line bar resaws benefit in a number of ways. First, the head sawyer, rather than cutting the log all the way through to the final board, is now only responsible for opening the log and quickly passing the log, thus increasing the number of logs processed per day dramatically. Secondly, the saw kerf or blade thickness at the line bar is less than at the head saw, which allows for more boards to be produced from the same log.
okay. So that's a pretty great overview, really, of what the manufacturing process looks like. For somebody that's never seen a mill run before, that's a really high performing mill. And they're really doing things pretty well. I found that video to share, and I was really impressed with how they went about the manufacturing process. And you say, well, they're chewing up a whole lot of logs. How does that look? Why is it needed? Well, here's an example. I just pulled some species. As we know, there are multiple different species of wood. And so I wanted to talk about what kind of products that are made out of those, just as an example. The first one I have here is ash, and ash is made into baseball bats, wooden baseball bats, for which the Major League Baseball teams go through thousands of baseball bats annually. There's a lot of baseball bats sold in America. Ash is the primary species of wood that makes that happen. White oak is made into stave barrels. Stave barrels is what wine and whiskey is fermented in and processed in. And so a lot of alcohol is consumed in America. White oak is the primary species used in that manufacturing process. And then there's poplar. Poplar is made into cabinets for your home or trim for your home. Hickory, made into hardwood flooring for your home. Maple, hard and soft maple, is made into furniture for your home. And if you say, well, I don't play baseball and I don't drink and I don't live in a home, why do I need, what still has it affected me? Well, I would say that the phone in your hand, the computer on your desk got to you somehow, and that way was a tractor trailer. And red oak lumber is made into tractor trailer flooring. So if none of these other ways affect you or your family, which I'm sure they do, but if they weren't, still every tractor trailer running up and down the road today has a red oak floor in the bottom of the trailer. And so there's just multiple aspects and avenues where wood consumption is necessary. And then what might be most important for today is sustainability. Okay, I know we get a bad rap with a lot of folks for how we affect, or at least they perceive that we affect the environment. Okay. And so is it economically or environmentally friendly? Are we depleting natural resources? Well, let me start here with this. I would say that a disproportionate amount or a larger than usual amount of forest products companies are generational family companies. Otherwise, they didn't start it themselves. Their fathers, grandfathers, in my case, my great-grandfather started a company. And and my son is 10, and it's absolutely the only thing he's interested in work one day. He told his sister last night on the couch, he said, Annie Grace, I hope you go to college because I'm dipping out after high school because I'm going to work with my, which is funny because I've had my fair share of university training, but to Max, he just can't wait to get in the law. So here's the thing. If for no other reason, these family operations want to see the forests and the environment healthy in order to sustain operations down the road. Okay, so that it really truly is our goal. That's not always been our goal. And here's why I say that you have plenty of reason to think that we're adversely affecting the earth. From 1850 to 1920, America, the country as a whole, lost 300 million acres of natural forest land. How much is that? It's 8 times the size of our state of Kentucky. 8 times the size of the state. Forest depleted. They were just truly harvesting, cutting timber down and ruining the earth. Okay. Deforestation is a real thing. It is happening in America and it does happen across the world. It does. I don't want to say for a second it doesn't. But in 1912, the Kentucky Department of Forestry was created, and it was created with a few goals, but namely the goal was to stop the deforestation and to bring some sensible, reasonable foresting laws into existence. Now, I will tell you this, without humans, nature takes care of itself. Forests will manage themselves if we leave them alone. But the way that happens is typically through forest fires, okay? And it takes hundreds, if not thousands of years to see those cycles occur. So not in our lifetimes would we be able to see the growth cycle of forests, okay? But with proper forest management, and that does include timber harvesting, proper forest management promotes health and growth. And I have here, ladies, think about trimming your hairs, dead ends to see faster hair growth. So we all know we need to trim from time to time. And when we do, we see faster hair growth. That's typical, okay? The same comparison can be made to Kentucky's forests. So that's kind of what we're doing. So humans have done a poor job of managing our forests, but Kentucky's forests now are being managed in what I believe is one of the most sustainable, best practices ways in the nation. Now, let's talk about this quickly. Here's the unhealthy way, okay? Large trees, this is just a simple cycle. Large trees see the most sunshine, catch the most rain, okay? That's pretty common sense. We don't have to have our PhD to understand that. The larger trees see the most sunshine, their leaves catch the most rain. They grow taller, okay? Because of they're absorbing what they need for life. They grow taller, and they even more so block out the sun and steal more of the rain from the smaller trees, okay? And the smaller trees then have stunted growth. In time, the larger trees die, and the dying trees that are still taller than the smaller trees continue to block out the sun and steal the rain from the smaller trees, and the smaller trees still have stunted growth. That's the natural way. Now, what I should have put on here is eventually lightning will cause a forest fire and burn up the dead trees, eventually. Okay, that will allow the smaller, younger, greener, alive trees to begin to thrive. But again, literally takes hundreds, if not thousands of years to make that happen, okay? Here's the healthy way. Large trees see the most sunshine, catch the most rain. Larger mature timber is then harvested, okay? We go in and we cut the mature timber and harvest the mature timber, sell it to sawmills or cut it in our own. And what just happened is we have opened up that forest canopy so that the sun will hit the smaller trees, the rain will hit the ground instead of being caught by the trees. And then we're evening out the opportunity. We're making it more equitable for growth on the forest floor. Properly managed forests lead to faster growing trees. That's, if I could leave you with anything with regard to sustainability, that's what I would leave you with. Properly managed forests lead to faster growing trees. Lastly, Kentucky Master Logger Program was created and mandated in 1998 that required all logging crews in Kentucky to have one master logger on site at all times, okay? This is how we're doing what we're doing well. Those master loggers have to have initial and then continuing education that talks about the rules and regulations with timber harvest, soil and water management practices to prevent erosion and make sure the ground is safe for renewed growth, best practices of timber harvest that promote sustainability. So we're doing things well on paper. And here's what I know to be true also is we're doing it well, and we can quantify that data because over the last 70 years, Kentucky has had a radical growth, and its forests, our woods and forests are healthier now than they were 50, 60, 70 years ago. Now, half of the Commonwealth is covered in forests. And that, to me, is an awesome stat. I love it. And I think that it's indicative of the science behind what we do. We're not slash and burn foresters. That might have been the case decades or years or maybe a century ago, but it's just not the case any longer. We're doing things well these days, and I'm very happy to say so. So with that, I'll leave it open for questions if there were to be any, Mr. Justin.
Yes, so we do have one here that's kind of a broad one, but how would you describe maybe the most difficult part of your job? So it can be, the stuff that's actually out in the forest working, or maybe it's some of the behind the scenes work that you have to do.
Sure.
How do you describe that?
Yeah, well, to me, it's an economic issue, which economics is a science too. So what happens is what we struggle from what I've called for years two-way competition. So every business in the world has to compete to sell its products, right? We know that, that's not a surprise. But with forest products industry and sawmilling, we also have to compete to buy our logs. So there is a finite amount of timber. And so what we find is, especially having been in this business nearly 7 decades and having established really great relationships with customers, what we find is that it is much more difficult to find, procure, and purchase the timber than it is to find, manage, and sell lumber to customers. So the most difficult thing to us is buying adequate amounts of logs and timber, not because there's not enough forest, but it's a resource that a lot of folks want to hang on to. And so to us, our deal is we have to buy it well at reasonable prices for margin, and make sure, because it is an organic it's an organic resource, make sure we're not buying it a year in advance and it's going to rot by the time it's time to process. So that management and procurement of our only raw material, which is a log, is the most difficult thing about our industry.
Certainly, yeah, for sure. So we are closing in the last few minutes of our Youth Science Summit. So I just want to kind of leave you with a question that we've had across kind of a lot of our speakers. But what would be some advice you would give to our students here, as far as maybe especially if they're trying to figure out what they want to do moving forward? And I think you bring up a great point that sometimes college is not for everyone. Yeah. As well, and so they want to try to figure out what they want to do, and what kind of advice would you give them on what they should focus on, maybe in school, in high school where they are, or middle school, for some of our listeners, about what they should be focusing on now that still will set them up for success in the future?
Sure. I'd be happy to talk about that briefly. Here's what I know to be true, guys, is that I'm 35 years old. I'm in the middle of my PhD work. It's coming slow, but it's coming. Hope to be done in a couple of years. My father graduated high school barely. Okay. My grandfather didn't. He quit his junior year of high school. I don't recommend that. What I would say, though, is that it doesn't take a PhD to be successful. My son he might be going the right direction. If he's not interested in that field, then you know what? There is a dramatic shortage of plumbers in this country. There's a dramatic shortage of residential electricians. You don't have to have a decade of university training to make a good living for your family. To earn good money. I mean, like vacation money. I'm not talking about barely skimping by. You could do well in other fields besides, being heart surgeons. We have to have heart surgeons, but it doesn't have to be you. If that's not your vibe, that's perfectly okay. Find your thing, figure out what your thing is, and pursue it.
Awesome. Thank you so much, Jordan. And thank you so much for speaking with us today for our Youth Science Summit. We're going to come to a close here. Thank our sponsors again. But Jordan, thank you for your advice. Thank you for your perspective and your understanding and of your industry, and something that I know I definitely was not very aware of. So it's educational for me as well. So I hope you have a great weekend, great week for yourself, and good luck. Thank you so much.
Thanks. We'll see you soon, Justin.
All righty. Well, thank you all for joining us here at our Fall 2022 Youth Science Summit. Once again, I want to thank our sponsors. That is Lexmark, Toyota of Kentucky, and Kentucky EPSCoR for helping make this event possible, help us kind of bring on these speakers from all different fields, all different levels of research, different industries, talk a little bit about all the different ways that we can use STEAM, science, technology, engineering, art, and math in such amazing careers and fields of research. So thank you so much for joining us. We hope to see you again. We will be bringing back our our Youth Science Summit in spring of 2023 with another slew of amazing speakers from lots of different fields all throughout Kentucky. And so we hope to have you be a part of that as well. If you have any other comments, questions, you can email the digital programs at kysciencecenter.org. For any of our speakers, we can get those passed along for your students or your classroom or for teachers, anything along those lines, we can get you connected. If you have, we will be sending out a follow-up email to everyone who's registered to just touch base on number of participants, how you felt it went, how the speakers were, just kind of get some of that feedback as well. So thank you so much again for joining us. And we hope you all have a great rest of your week and weekend.